When we're looking at absolute value, the big idea behind absolute value is the idea that we have to consider the inside being either positive or negative. Okay, so we have to account for the inside of the absolute value being positive or negative. Okay, whether we're talking about equations or functions. So the first one here says state the function as a piecewise function. So it's stated as a piecewise function, we have to consider again the positive domain and the negative domain. So we're going to write it like this. So y is equal to, okay, we have the positive version of it and the negative version of it. So the domain for the positive portion of it is we look inside here and we determine the domain which is going to make that inside positive. So that's going to be when x is greater than or equal to 2. And then we can just write this equation as, take away the brackets, it's just going to be x minus 2 plus 7, okay, which we can then simplify to x plus 5. Okay, so again, it's because we can leave it as x minus 2, and then we have our plus 7. Okay, that combines and simplify those terms, it becomes plus 5. Okay, then we have to consider when the inside is negative. Okay, so we're talking about the inside now being negative. So this inside is negative. Well, we have to establish the domain. It's going to be the opposite of the positive, so it's going to be less than 2. So when x is less than 2, the inside is going to be negative. Well, if the inside is negative, we need to take the opposite of that inside. So we're going to have x minus 2. But because that's negative, we need a double negative to make that positive, because that's what's going to happen when we absolute value it. So we're making it positive by using that negative on the outside, and then we're going to do plus 7. Simplifying this, I'm just going to do it underneath. I end up with negative x plus 2 plus 7, so that becomes plus 9. So my piecewise function is going to be made of those pieces here. It's going to be made up of x plus, it's going to be made up of x plus 5 when x is on the right side of 2, and it's going to be equal to negative x plus 9 when it's to the left of x equals 2. So this is, again, the big idea, is that we are looking at the positive and negative versions. Oops, let me just get rid of that. We're going to be looking at the positive and negative versions of the equation, and that's based on the domain, and we can establish that way. So we'll do the same thing here. We end up with y is equal to, we're going to split this up into the positive version, okay, and the negative version. So we're going to look at the inside and establish the domain when it's going to be positive. If it's positive, we don't change anything, because when it comes out of the absolute value, it's going to be positive. So the domain is going to be when x is greater than or equal to back over front, so negative 2 over 3. Okay, so it's just like factors. I can find the boundary when it's equal to 0, and then I want the right-hand side or the positive side of that. Once I establish that, I can then take away the brackets. That 3x plus 2 can just stay the same, and plus 4. And simplified, that becomes negative 9x minus 6 plus 4, so minus 2. Okay, so that establishes the positive version of that when we start at negative 2/3 and go to the right. There's also the negative domain of this, and the domain is going to be based on when x is on the other side, so less than negative 2/3, And then when we do this, we're going to get negative 3. And the 3x plus 2 is going to be negative. So to make that negative positive, we're going to introduce that extra minus on the outside. I'll just highlight that extra minus. Okay, we're talking about this little bit extra minus there. Okay, so then we have that. And then we're going to have the plus 4 on the outside. Okay, so we're just going to simplify this. This is a double negative, so it's going to be positive 9x. We're going to end up with positive 6 plus 4, so that becomes plus 10. Okay, so on one side we're going to have the red equation, the other side we're going to have the green equation. Again, if you're kind of thinking about what this looks like, okay, we're going to have our graph here. It's going to be at negative 2/3 and positive 4. That's where our vertex is, negative 2/3. I get the plus 4 from this number here. Okay, and then on the right hand side, I get a line with slope of negative 9 and a y-intercept of negative 2. So when I draw that in, it's going to look like this. Okay, on the left hand side, when x is less than negative 2/3, I'm going to have a slope of positive 9, and if I were to extend that, the y-intercept is at positive 10. But again, it's going to stop at that point because that's where our domain restriction lies. Okay, so we don't actually have that part of the graph.